Hello. Hi guys, good morning. Welcome back to a new video. Ki hal chal? I hope you guys are doing good. In this, we're gonna see a problem. Count unguarded cells in the grid. So what we are given is we are given a specific grid. As you can see, a grid of size 4 cross 6, 4 rows, 6 columns. 1, 2, 3, 4, 5, 6. Now we are also given some guards. These are location of guards 0, 0, 1, 1, 2, 3, and then we are also given some walls 0 comma 1, 2 comma 2 and 1 comma 4. Cool. Now a guard can see every cell in the four cardinal directions. So a guard can see every cell in his four cardinal directions until starting from their position unless obstructed by a wall. So this guard can see in all the four directions until it reaches the end or is obstructed by a wall. And same way this guard can see all in its all four directions until reaches the end or is obstructed by a wall. This guard also can see in all four directions until reaches end or is obstructed by a wall. So after we see, okay, where all these guards can actually see, we have to return the number of unoccupied cells which are not visible by guards. As you can see, all these green locations are the cells which are unoccupied by this guard. Thus the count is 1, 2, 3, 4, 5, 6, 7. Now, a very basic brute force simulation simply says that from every guard, simply traverse in all of its four directions. For example, if I take this guard, I will start traversing in its four directions horizontally and vertically. And I will keep on traversing and marking the cell as visited until I visit a wall. And same way here also, here also, here also. I'll simply visit in the four directions. Starting from, let's say the cell is R comma C. I'll go to the next cell which is R comma C plus 1, R comma C plus 2, and I will keep on going until I visit a wall or I visit the end of the grid. Same way I will visit R comma C minus 1, R comma C minus 2 until I visit the wall or I visit the end. Same way I visit R plus 1 comma C, R plus 2 comma C until I visit the wall or I find the grid end. Same way I keep on visiting up, which is R minus 1 comma C and so on and so forth. Now, what is the complexity? Obviously, we are given, if we look at it, we are given a grid. Now, that grid is m cross n size. So, firstly, I will make a grid. Then, for each card, I am traversing in four directions, which means up, bottom, right, left. So, I will at max traverse the entire vertical portion and entire horizontal portion. That's it. So for each guard, this will be the complexity. Now it might feel like that this would work, this would not. For the folks who think this would not work, let's see why you think of this fact. Obviously, if I take consideration that I have a m cross n configuration as 1 and 1e5, because there is no limit on n and m individually, there is a limit on n cross m, which is 1e5. So I can imagine a configuration where I have one row and it has 1e5 number of columns. And also in that configuration, imagine I have maximum number of guards, which is 5 into 1e4. So if I exactly put these configurations in above time complexity, we will easily see this will give TLE. This will be 5 into 1e4 and this will be 1 into 1e5, which is roughly around 5 into 1e9, which is obviously more than 1e8. Again, roughly 1e8 is what works. So again, usually we try to have it less than 1e8, but 1e8 is at max. Beyond it, there's impossibility. Like it is impossible to make it work. So obviously, we realize that this is giving us TLE. Now, before we even realize why it is giving TLE, let's see what's actually happening and why it is giving TLE. This is giving TLE because for this specific card, it will go to in its entire horizontal place an entire vertical place. Imagining I have only one row, so forget about the vertical, only think of horizontal. So this guard is traversing the entire horizontal and marking the things as visited. This guard also is again because the condition which we saw above was until it finds a wall or it finds a end of the array. So neither there is any wall here and end of the array is here. So it will also keep on visiting every cell up till the end. This guard 3 also will keep on visiting every cell until the end. This guard 4 also will keep on visiting every cell until the end. And this is the exact reason why we are getting TLE. Now, there's a very basic stuff that when we know that this guard 1 has visited these places, then why do we even need other guards to even visit it? It's a unnecessary visit being happening. So what we should do, we should simply not visit something which is already visited. That's the first intuition which we can get. So if we do the same stuff, now my question will be, for this guard, let's say I repeat the visiting again. So okay, let's say I visit this, visit, and also he'll visit. And obviously you are saying that this guard will visit the entire stuff, which means this guard will visit the entire thing. Visit again. This is when I say guard 1. Visit. Now what happened to guard 2? Aryan, are you saying that guard 2 should not visit? Ideally, yes. Guard 2, because considering you have visited everything, so guard 2 should not visit anything now. So technically guard 2 should not even start traversing whatsoever. But do you see a loophole here in this condition where you completely visited it, and now to even think, to even imagine visiting any other place, you went on to your neighbor, you saw it is already visited, so you stopped your traversal. Do you think this will work? I'll give you 1 second. Okay, this will not. Because take the exact same example which is given to you. When you started from this specific guard, you visited, okay, its left, and again, when I say horizontal, you visited its vertical, this is done. Then next time you visited this specific cell guard, you had to start traversing it. You saw, oh, it's already visited. So you actually stopped here, which is incorrect. Because you should have traversed it entirely, because else you will never be visiting these specific cells which were technically bound to visit. So what is the issue with this approach which you saw above? Obviously I cannot, obviously I cannot make the specific places visit again and again, and obviously I cannot imagine I will visit everything and I will not visit that place because things are already visited. So I have to find a middle ground between these two approaches. What is that specific middle ground? That specific middle ground simply says that if I look back at my first case where I was visiting these places, I realized that it is obvious if a guard is here, anything in its direction will always be visited. Again, I'm saying anything in its direction will always be visited. So if I'm coming to a guard in a specific direction and I find another guard, I should stop there itself. And thus, what will happen with this is that this specific guard will come up till only this point. Let's erase entirely. Yeah, this specific guard will come up till only this point. This specific guard will come up till only this point. This specific guard will come up till only this point. Thus, this guard 2 is visiting all these locations, this guard 3 is visiting all these locations, and this guard 4 is visiting all these locations. Now you might ask, Aryan, what about roundabout? Like obviously, this guard 1 will also be able to visit either up till the wall or the grid end or until the next guard, which is this specific guard. And this is required. Else I will be having condition if I just believe that if something is visited, I should not visit it again. That's not necessary, because I have to make sure even if some place is visited, still I will traverse it until I find the grid end or a wall or another guard. Now I ask you, what is now the worst case? Now the worst case can be if I have one guard here, one guard here, one guard here, and one guard here. These guards will again, let's say this specific guard will visit. This guard will again do a visit. This guard will again do a visit. This guard will again do a visit, visit, visit. So in worst case, any cell can be visited at max 4 times, and that is itself its worst case complexity, that any cell is being visited at max 4 times. And again, this is a worst case, it cannot go beyond it, because even if I have another guard here, it will keep on traversing and will find, okay, I already have a guard, he will stop. If I have another guard here, then he will traverse, he'll find, okay, I have another guard, it will stop. So in worst case, a place or a cell can be visited at max 4 times. And ultimately, this is your complexity, that you will firstly make a grid of size n cross n, then obviously you will be traversing, but in worst case, you will actually be visiting at any cell. Again, it is much lesser than 4 into n into m, because this actually, I told you a very specific worst case, but obviously the things are more sparse in the grid. But still, any cell cannot be visited more than 4 times, because anytime I see another guard in my direction, I will simply stop. So now the stopping condition is the grid end, another wall, or another guard. These are the stopping condition which makes us get to the time complexity. And again, obviously we are making a grid, so space O of m into n. Let's say the code is exactly very simple. Firstly, I make a grid and I marked every cell as empty. Then I marked all the guard cells with the guard. I marked all the wall cells with a wall. Then I started to visit all of my, again, when I say guard, I will start from each guard, and then I will visit in its vertical direction and his horizontal directions. So I'll simply visit row and columns. What this visit function does, this visit function, if the guard is at r comma c, it will start from r minus 1 comma c and will keep on going up. So as you can see, I start from r equal to row minus 1, and I will simply keep on going up. I will stop only and only when I find a wall or I find another guard. Then I will simply stop. Else I will simply keep on marking those cells as visited. Same way I will go down, same way I'll go left, same way I'll go right. And again, you will see I'm only stopping when I am finding another wall or another guard. And again, my grid is being maintained by these conditions, that I am not going out of my bound of my grid. And ultimately, when I have visited, I will simply come back to my grid and check all those cells which are not a guard, not a wall, and not visited are ones which are not visited, and I should count them. Ultimately, this is my count. I hope you guys got it. I hope you guys got the complexity portion of this, and how we reach to a middle ground. When things don't work out, you actually have to reach to a middle ground. Bye bye, take care, and do follow us on Twitter. We are pretty active right now. Bye bye, take care.